In this video, we will explore some business applications that use the exponential form. The most common of these is going to be in financial math, where we have compound interest and the compounding is occurring continuously. In this case, we have to use the PERT formula, where S is equal to PE to the RT. Okay, so let's get started with this concrete example. Let's suppose that P dollars of principal is invested in an account compounding continuously at 4.2% APR. Then the future value after T years using the PERT equation is going to be S is equal to PE to the 0.042 T, and that's because this rate right here is an annual percentage rate, so I had to take this percent and divide it by 100 before I stick it right here as a decimal into the PERT formula. Now that we know calculus, we can start to answer questions about the rate of change on this function. At what rate is my money growing after 2 years? Now, first of all, what is this sentence translate into in terms of math? If I ask you at what rate is the money growing, or what is the rate of change of my future value, what is that speaking to? The derivative, right? The derivative is the rate of change. So this question is going to be answered mathematically by finding S prime evaluated at 2 years. Okay? Now, if we want to find the derivative evaluated at a point, we must first find the derivative as a function of the independent variable. Here, the independent variable is t, and we're going to assume that p is a fixed amount that we invested. Okay? So we're going to find ds dt, or if you want, s prime of t, where s is just a function of t. Okay, so hopefully you've already seen the videos on derivatives of exponentials. Go ahead and take the derivative of this, and I didn't give you a number for p right now, so just treat the p as if it were a number, okay? So your answer here is going to have the letter p in it, but just pretend that p is a number while you're taking the derivative of that with respect to t. Alright, so what answer did you get there? Well, the derivative of e to the t would be e to the t, right? So the derivative of that, just carrying the p through because it's a constant multiple, is going to be e to the 0.042t. And then don't forget that that wasn't just a t up there, it was 0.042t. So we must also multiply by the derivative of the inside function to get 0.042 right there. Okay, so that's the derivative. Now I'm inside a word problem right now, so what are the units on that derivative? It's y units over x units, right? Just like every time. So the y is a future value, and that future value is in dollars. And the x, or independent variable right now, is t, and t is in years. So the units on this derivative is dollars per year, that's right. So this is dollars per year, and the reason I care so much is because that'll kind of lead me to interpreting what this number actually means. At what rate is it growing? It's growing at a rate of this many dollars per year. So if I leave it for one more year, I'm going to get this many more dollars. Okay, but it's not this many until I actually put some numbers in here. So first of all, let's let t equal 2. So s prime of 2 is going to be p e to the 0.042 multiplied by 2. And then don't forget that you had the 0.042 right there, and that's in dollars per year. Okay, so let's see, maybe I need a number for p as well so that I can put everything together and start to get a real number out. So let's also let my principal investment be equal to $1,000. Okay, so saying that my principal value is equal to $1,000, now what is s prime of 2? That's going to be 1,000 times e to the 0.084. And then don't forget to also multiply by that 0.042 right there. And then in the end, we get the amount $45.68 per year. Okay, good thing I have the units on there because that really helps me to understand what this number is that I'm actually crunching. What it says is that if I invest $1,000 inside this account, that on my second year, after I've left it there for 2 years, the amount of money that I can make going from my second year to my third year, so within the next year, is that my money's going to grow by $45.68. Okay? Now, if you answer this question again for S prime of 3, you would see that S prime of 3 is an even bigger number. Go ahead and plug it in. And what about if you answered it for S prime of 4? That would be an even bigger number still, because it turns out that compound interest is actually growing at a rate which is also exponential. You see, the exponential form is still present in the derivative because the derivative of exponential is still exponential. And that's actually amazing. That's great for me because exponential is the fastest growing function out there. So what it means is that my money is not only growing, but it's growing at a faster and faster rate every year. For example, on the first year, putting in $1,000, I'd expect to make at 4.2% APR about $42, right? And that's about how much I would make, a little more than that in the first year. But between the second and third years, I'm going to make a little over 45. Between the third and fourth years, I'll make a little more than that, and a little more still. It's growing at an exponential rate. So that's really nice for money. Okay, but now let's do one more application where I'm going to give you a total cost function, which is in an exponential form. And then we'll consider what's happening to the marginal cost, which is the derivative, and that will also be exponential. Let's say that we have total cost in dollars to make X items, so X is in items, is C of X is equal to 10,000 plus 20X e to the X over 400. Okay, so that's the total cost, and the question for this example is find the marginal cost when 200 items are produced. And keep in mind that the marginal cost is the amount of money that it costs me to just make that one more item. So this will be actually the cost of just the 201st item. That's also an equivalent interpretation of that answer. Alright, if we want to answer this question, as usual, we will approximate marginal cost with the first derivative of total cost. And so this question really just boils down to actually just find C prime at the number X is equal to 200. So find C prime of 200. Okay, so first we're going to have to find C prime, and then we're going to plug in X equals 200, and we'll be good to go. Alright, here we go with the C prime. We're going to take the first derivative. The derivative of 10,000, doesn't matter how big the number is, the derivative of all numbers just goes to 0. So that just goes to 0. Next up we have 20 times X, then times e to the X over 400. This one's going to be a little complicated. This is actually a product. Well, the 20 is just a constant multiple, so the 20 can just stay right there. But what's the product part? We have an X times e to the X over 400, and we can't escape the fact that that's a product. So we're going to have to use the product rule, where we're then going to get F prime G plus G prime F. Okay, the F is going to be X, and the G is going to be e to the X over 400. Alright, let's get started on the product rule. F prime, what's the derivative of X? Just 1, right? So that's just a 1 there. And then times G, so I'm just going to leave the G function alone just like that. And then plus G prime, and this is where your new knowledge is going to come in. What's the derivative of e to the X over 400? Try that right now. Well, e to the X goes to e to the X, so it's going to be e to the X over 400. What did I forget? I have to multiply by the inside function's derivative, right? And that's 1 over 400 because the inside function is X over 400. So its derivative is 1 over 400. And then don't forget that that's all times F, which is just X right there. Oh boy, so that is actually the expression for C prime. Okay, well, the question asks for what's the marginal cost at 200. So I just have to evaluate C prime at 200. So that's going to be 20 on the outside times e to the 200 over 400. So that's e to the 0.5. And then plus Now don't forget, right here you have a 200 over 400 right there, and then you have e to the 0.5 once again, okay, and then you have to crunch all that stuff out, and eventually the number you're going to get is $49.46 per item. Keep in mind the derivative still has as its units y unit over x units, so that means it's costing me $49.46 to produce just the 201st item. All right, that's great.